Hello everyone. Alright, so grade 9, 3.4, equivalent linear relations. Basically all that means is that two or more equations written in different methods or different looks but are in fact the exact same line. Okay, so let's use this particular equation for our first example. Now, what we're going to do is we're going to graph this equation using a different method than we learned in 3.3. Okay, we're going to use something called the intercept method, where we need the x-intercept and the y-intercept. And all that means is that the line will cross over the x-axis and the y-axis. Okay, x-intercept, y-intercept. All right, so let's get back here to the equation. Well, if it's going to cross the x-axis and the y-axis, what happens is two particular rules, all right? So think of it this way. If I was looking for the x-intercept, okay, that would be the x-axis. The y value for any point on the y-axis is 0. In other words, you'd have 3, 0, 5, 0, negative 2, 0, a location on the x-axis. Well, if I know it's on the x-axis, then what I'm going to do is I'm going to solve for the x-intercept by letting y be 0. So I set one of the parameters and I solve for the other number. Okay? So here it is. Now, unfortunately, I have both up, so I apologize. But here is 5x minus 3 times 0. Okay? And what that does is it kicks out the y term so I can concentrate on only the x value. All right, so there's 3 times 0. Now I can solve for what x is when y is 0. Okay? So that would be my x-intercept. Similarly, if I can do the x-intercept, I can do the y-intercept. I'll let x equal 0 this time. So whatever intercept I want, I let the other letter be 0. Okay, substitute in, solve. What do I do with these two intercepts? Well, they're locations on the graph. So let's take a look here. All right, so here's your XY graph. Now, to save time and a little bit of effort, I basically drew a very simple XY graph. And here is the y-intercept at 0, negative 5 would be its location. Because remember, any coordinate needs both x and y. So x is 0, y is negative 5, and its y-intercept is at 3, 0. Now, when you draw any line, you only need 2 points, and these are your 2 points. So I take my ruler, connect the dots, there's your equation, graphed on a line, on a Cartesian plane, an XY graph. Okay? Now, just to show you that this is one look, okay? The other day, in 3.3, we did y equals mx plus b. So let me just get this. Okay, we use the form y equals mx plus b. So if we were to take this equation, 5x minus 3y equals 15, and rewrite it, it would start to look like this. Okay, so there's the original equation. Now, to make it look like y equals mx plus b, all right, what I'm going to do is I'm going to write y equals mx plus b at the bottom. Notice, format look, all the equal signs line up. So basically, I want this equation to look like that. So the first thing that has to get kicked over is the 5x. It's on the wrong side. When you bring it to the other side, it's minus 5x. Okay? Notice I have the x before the 15, because I want mx plus b, b being just a number, okay? Next, I don't want negative 3y. I want just a y. So what I'm going to do is I'm going to divide out by the coefficient in front of the y. In this particular equation, it's negative 3. And what I do to one piece, I have to do to everybody, okay? I have to be clear and equal to everybody, or else somebody gets problematic. So now I've gone from this look to y equals mx plus b. Now the reason I did that, two reasons. One, you're going to be responsible for rewriting your equations from one look to the other look, okay? So this is how we would bring it back to y equals mx plus b. The second reason is you already know how to graph using y equals mx plus b. We plot the b point first, -5. Then we do rise of 5, run of 3, and connect the dots. And if you'll notice, coincidentally, that's your -5, that's your 3, just like it was above. Okay? So whether I have it in y equals mx plus b, or I have it in this look, okay, it is the same equation. It is the same line. All right, well, the first thing I'd like to introduce you to is types of equations, okay? And basically, these are just basic names. So the standard look is some number times x, some number times y, plus a third number equals 0. That is the standard look. And all it is all the numbers and all the letters, variables, sorry, are on one side. But we can have semi-standard, and all that does is it leaves the xy on one side and the number without a variable by himself or herself on the other side. And then, of course, the third method that you remember from the other day, y equals mx plus b, okay? And that's called your slope-intercept because of the m and the b in that order, okay? Basically, each name has a different look, okay? Each name is basically just a different look, but it's the same equation and it's the same line when you graph it. All right, let's get to the next section. Okay. All right. Now, you should be able to rewrite the equation going both directions. What do I mean by that? Well, let's take a look on the left side first. Let me just move this over a bit so I don't show you too much. All right, so here it is in semi-standard form. And what am I going to do? I'm going to rewrite it so it's in y equals mx plus b. Okay? So again, the 4x goes over. When it switches sides, whatever was a plus becomes a minus, right? Because it's on the wrong side. And then I don't want 5y, I want single y. So I got to divide by 5. And what I do to 1, I have to do to all 3 to be fair. So here's my new equation, my new look. I switched it from semi-standard to y equals mx plus b. But you should be able to go the other way as well. So let's take a look at another example. Okay? All right. So, first things first. I have this nasty looking equation, especially with a bunch of fractions. No problem. Okay? What I'm going to do, oh, sorry. I meant, okay. I'm not going to restart this video because I'm already 8 minutes in, all right? But basically, here's a nasty looking equation, and I still want to make it y equals mx plus b. So the first move for this is to change it into a common denominator. Okay, the 5, the 4, and the 1 all meet up at 20. As I manipulate the denominators, I have to equally manipulate the top. So for example, 4 times 5, so 4 times 2x. This is how I get 8x, 15y, and -40. Okay? Once we are all on the same level, same floor, 20, 20, 20, then what I can do is I can concentrate on the numerators. Just the 8x, just the 15y, and just the 40. Now I'm going to rewrite it into y equals mx plus b. Okay, I'll just get that out of the way. So again, like before, the 8x moves first. And then I'm going to divide out by the -15 because I don't want 15y, I want just y. Okay? When I divide out by -15, you'll notice this is not a simple equation. It's not nice numbers, but it doesn't matter. Here I've got negative by negative, positive, 8 by 15 does not reduce, so it stays 8 by 15. On the other hand, I've got negative 40 divided by negative 15. That's how I got the plus. And 40 and 15 have a common factor of 5, which I can divide out. Hence, 8 over 3. So what looked like a nasty looking equation can be rewritten into y equals mx plus b. All right? All right, let's go to page 2. All right. So here is y equals mx plus b. I need to be able to rewrite it into semi-standard. Okay? So the first move is to find a common denominator. I've got a 1, which wasn't there before, the 5, and the 2. All right? So what am I going to do? Well, that makes a common denominator of 10. Okay? And whatever I manipulate the denominator by, I have to do to the top, right? So 10 times 10, 10 times 1, so 10 times y. Got it? All right, so now that everybody's on the same floor, okay, then what I can do is I can concentrate on the numerator. 10y, 8x, 15. Now that I have it in this format, okay, I wanted semi-standard, which means the x and the y are on the same side. So now I have to bring the 8x back. Okay, and when I do that, it switches sides. Negative 8x plus 10y equals negative 15. Okay? But I have it written here so that you would, whether you listen to my lesson or not, you would have seen it. Math has a tendency to have the x term or the lead term positive whenever it can. Okay? It doesn't care about the plus minuses on the other as much, but they'd like to see positive 8x and then whatever follows, follows. Okay? Well, the way to do that, to get this to become a positive 8 instead of a negative 8, is to divide out by negative 1. And what I do to one piece, I have to do fairly to everybody. So if I divide each term by negative 1, what does it do for me? It gives me my positive 8x, my front term, positive, like I wanted. And it turns out that the 10y is negative, so that's fine. And the 15 becomes a positive this time. That's fine too. All right? Now, I want to show one more example where we graph a difficult-looking equation using the intercept method instead of y equals mx plus b. Here's the reason. Okay? That is an ugly-looking equation. To switch it around into y equals mx plus b could be a problem, could take a lot of time. So instead of switching it, I'm going to take advantage of my x-intercept, y-intercept. Okay? Now just to show you, I did y-intercept first this time. It really doesn't matter because you need both points. So whatever intercept I want, the other letter has to be at 0. I want the y-intercept, x is 0. Plug it in. Now the advantage of plugging in at 0 is that you're going to have the 3/5 get lost, right? Because 3/5 times 0, gone. So that leaves me now with negative 1 over negative 1/6 times y. All right, equals 2. Next, I need a common denominator of 6 in this case. Okay, so this is what we've got. Since both denominators are on the same floor, effectively, I've got negative y equals 12, but I don't want negative y, I want 1y. So I'm going to divide both sides by negative 1, hence my y-intercept is negative 12. If I just drop this a little bit more, you'll see there's my y-intercept, negative 12. On the x-intercept side, I'm going to let y be 0. Okay? What does that do for me? Well, 1/6 times 0, gone. So now I can concentrate only on the x term. Again, I need a common denominator. Once I have the common denominator, I have 3x equals 10. I'm going to divide both sides by the 3 so that I get x equals 10 over 3. Or for those of you who don't like massive fractions like 10 over 3, 3 1/3. So when I go to graph this, here's x equals 3, here's x equals 4. With reasonable abilities, 1/3 is a little 1/3 of the way across from 3 to 4. Close enough. There's my 2 points. Connect the dots with a line. All right. So I have here the homework. Now I ask you again, please. All right. When you're doing this homework, I'm not expecting you to do every question. If you want to, go ahead. But be selective. Do 1 out of every 4 so that you get a good look at the different fractions and questions that are out there. All right? All right. Hopefully that wasn't too long an explanation. Have a great day.